This is the key to the quiz on solving compound inequalities. And so we have, in number one, we have this linear compound inequality. And one of the things that makes this a linear compound inequality is the fact that you have two inequality symbols. And so we want to find the values of x that will make this compound inequality a true statement, meaning this, meaning that whatever value of x is the solution, -4 is going to be less than this value, and at the same time, this value has to be less than or equal to 11. The best way of solving this compound inequality looks just like this, is to get the value of x, the variable x in the middle by itself. That's the easiest way to do that. And so if this was not a compound inequality, but just a simple inequality, you know to solve this linear inequality, you would go ahead and add 7 to both sides, right? Well, the same idea. But there are 3 parts here, left-hand side, the middle, and the right-hand side. So you have to add 7 to all parts. So since I'm subtracting 7, the opposite is to add 7. Notice, add 7 to the left, add 7 to the middle, add 7 to the right. Now, combining like terms, -4 and 7 is 3. It's less than, these are opposites, so we can add them up, you get 0. You get 3x here. And that's less than or equal to, and then 11 plus 7 is 18. All right, now I'm going to go ahead and rewrite this over. Okay, now I want to get x in the middle by itself. Right now, notice this says 3 times x, right? The coefficient of x is 3. So to get x by itself, I have to divide all parts by 3. So division, because this is multiplication. The opposite of multiplication is division. And so now simplifying, 3 divided by 3 is 1. So 1 is going to be less than, 3 divided by 3 is 1. 1 times x is x. And that's going to be less than or equal to, and then 18 divided by 3 is 6. I found the solution. So the solution to the original compound inequality, all those statements are equivalent. So the solution is this. So any real number between 1 and 6, including 6 because of the equal sign, is going to be a solution to this compound inequality. No other real number is going to work that's not in this solution set. All right, now the directions said just to go ahead and write the answer in interval notation. So the answer to interval notation will be parentheses 1 because there's no equal sign. So remember, 1's not a solution. But any number between 1 and 6, including 6, so notice the bracket. All right. Now, there may have been some of you that did this instead. So the other approach is this. But if you're going to do the other approach, you must use the word and. That was mentioned before. So that's why most students will solve it this way. So the other approach is this. So you can always, this compound inequality is really an and inequality. So that means -4 is less than 3x minus 7, and at the same time, 3x minus 7 has to be less than or equal to 11. But you had to say the word and. You cannot leave that off. And is needed here. And then you solve each one individually. Again, most students will stay this way. We'll solve it the first approach. Okay, so adding 7 to both sides here, -4 and 7 is 3, is less than 3x. So see, this part here is this right here, right? This is 0. Dividing both sides by 3, I get 1 is less than x. So that is this right here. And over here, add 7 to both sides. This combined like terms, that's 0. I get 3x is less than or equal to 18. So that is this. See this right here? And divide both sides by 3. And simplify, and I get x is less than or equal to 6. And that is this. So doing this way, you then had to think about it this way in terms of the graphs. So if you look, 1 is less than x means the same thing as x is greater than 1. So what you found here is that any real number greater than 1 is a solution to this inequality. And any real number less than or equal to 6 is a solution to this. But remember, this is an and statement. So we got to find out which solutions here, and at the same time, which solutions here will make this compound, this and statement, a true statement. So that's where you looked at each graph individually. So here's 1, open circle going to the right because it's greater than. Here's 6, closed circle going to the left, and that's where you had to look at the intersection. So your interval solution then would be parentheses 1, 6 with a bracket. And that's what we got here. All right, so that's what you had to do if you did it this approach using an and statement, and you had to write the word and. All right, number 2 looks similar to number 1, except you had to remember one idea. So here's number 2, negative 4 is less than or equal to negative 3x minus 10 is less than or equal to 2. All right, so remember we had this compound inequality, so I'm gonna do this by using that first approach. I'm not gonna do the second approach here because most students will stick to this approach. All right, so I'm gonna go ahead, remember we gotta get x in the middle by itself to solve this compound inequality, so I need to know what values of x will make this a true statement. We'll make negative 4 is less than this, and this is less than or equal to 2. All right, so I'm going to add 10 to all parts. Negative 4 plus 10 is 6. It's less than or equal to, this is 0. Negative 3x is less than or equal to 12. I'm going to go ahead and rewrite this over. All right, now I got to get x in the middle. Right now I'm multiplying x by negative 3, right? The opposite of multiplication is division. But remember, I'm going to go ahead and divide all parts by negative 3. But remember, when you multiply or divide an inequality, both sides or all parts of an inequality by a negative number, which I am here, I'm dividing, you have to reverse the inequality symbol. So you had to reverse the inequality symbol. So this becomes greater than, equal to, greater than, equal to. And then simplifying, 6 divided by negative 3 is a negative 2, is greater than equal to negative 3 divided by negative 3 is 1. 1 times x is x, is greater than equal to 12 divided by negative 3 is a negative 4. All right, but remember we tend to write statements from smallest to largest. You know that negative 4 is larger than negative 2. So this statement right here is equivalent to this statement. Negative 4 is less than or equal to x, is less than or equal to negative 2. Those statements are the same. And so therefore your interval notation, you're going to say bracket negative 4 to negative 2 bracket. And brackets because of the equal sign. Negative 4 and negative 2 are also solutions. So the solutions to this compound inequality will be any real number, rational, irrational numbers, that's between negative 4 and negative 2, including negative 4 and negative 2. So for example, negative 3.68 is a solution, right? Because it's in here. Negative 3.68 is a solution. So any real number, rational or irrational, that's in here is a solution. And so there's an infinite number of solutions. Number 3. So number 3, we had an OR statement. So here's number 3. We had 4x minus 2 is less than 2, or 3x minus 9 is greater than or equal to 3. So we had this compound inequality with the statement OR. All right, so we got to solve each one individually. Now remember, when solving an OR statement, any solution here, so that's an OR statement, right? So your solution to this compound inequality would be any solution that's here or any solution that's here. Okay? So your solution will come either from here or from here. That's what that means. All right, so let's go ahead and solve each one individually. So I'm going to add 2 to both sides. So I get 4x is less than 4. 2 plus 2 is 4. Dividing both sides by 4 and simplifying, I get x is less than 1. So any real number less than 1 is a solution to this inequality. But since that's an OR statement, it's also a solution to the compound inequality in it. But let's see what happens here. We could have some more that's different from this one. So let's go ahead and solve this one now. Add 9 to both sides. I get 3x is greater than or equal to 9 and 3 is 12. Divide both sides by 3. I get x is greater than or equal to 4. And so what I found here is that any real number greater than or equal to 4 is a solution to this, but a solution to this as well. So then what that means is that any of these solutions here is a solution to the original. But let's go ahead and write this better. So let's look at this in terms of the number line. So here's 1 less than, and then here's 4 greater than or equal to. And so basically what that means is that the solution to this compound inequality will consist of 2 intervals. This solution here, which came from here, and this solution here, which came from here. So as interval notation, which you had to do, you're going to write it this way. Negative infinity, remember infinity, negative infinity is always parentheses. Negative infinity to 1, parentheses because it's an open circle, union, and then bracket 4 to infinity. And bracket because of the closed circle. There was an equal sign here. All right, number 4. And then number 4 was an and statement. You had 7x minus 8 is less than 6, and at the same time, 3x plus 7 must be greater than or equal to negative 4. Now, when solving an and inequality, your solutions, so you're going to solve each one individually. And so what you're going to do, though, since that's an and statement, is the solution to this compound inequality has to be what those 2 sets of solutions have in common. So that's where you look at the word intersection. With R, you look at the word union. So you're going to union those 2 solutions together. Here, you're looking at the intersection. Where do those 2 solutions intersect? So you're going to solve each one individually, just like you did in the previous problem. So I get 7x is less than, and then 8 plus 6 is 14. Divide both sides by 7. I get x is less than 2. So x is less than 2 is a solution to this inequality. Now remember, that's an and statement, so I cannot say that that's also a solution to this because of the word and. I've got to look at this and then compare the 2 because I need the intersection. Subtract 7 from both sides here, since I'm adding 7. I get 3x is greater than or equal to negative 7, and negative 4 is a negative 11. Divide both sides by 3. I get x is greater than or equal to negative 11 thirds, which is the same as saying x is greater than or equal to negative 3 and 2 thirds. So x is greater than or equal to negative 3 and 2 thirds is a solution to this one. Now what I need to do to solve the original and statement is look at those 2 graphs and see where they intersect. So here is 2 less than, open circle. Here is negative 3 and 2 thirds to the left of that. Closed circle going to the right, and they intersect here. So where they intersected is a solution to this compound inequality. So your interval notation, your solution in interval notation form will be bracket negative 3 and 2 thirds, comma, all the way to 2 with parentheses. And so that's it. So that was the key to the quiz on solving compound inequalities.